Boric acid is a weak Lewis acid of boron and is often used as an antiseptic, insecticide, or as a precursor to other boron compounds. One such being trimethyl borate, which I showed how to make in a previous video. Its chemical formula is H3BO3, which is shown on screen. A similar but weaker effect can be made to pure trimethyl borate when a mixture of boric acid and methanol is burned. To begin, 170 grams of borax was added to a beaker. This borax was then dissolved in 400 millilitres of distilled water. The solution was heated until all the borax dissolved. The heating was turned off and then 120 millilitres of 6 molar or 17.5% hydrochloric acid was slowly added. What's happening here is the borax is reacting with the hydrochloric acid to form boric acid, water and sodium chloride. I will separate the aqueous products by taking advantage of the boric acid's drastic change in solubility at lower temperatures, a property that sodium chloride does not share to the same extent. To do this, the solution was cooled to room temperature and then it was left in the fridge overnight. The following day, crystals of boric acid had formed around the side and base of the beaker. The sodium chloride solution with trace amounts of boric acid was decanted into a conical flask. Some of you may be thinking that I should be wearing gloves while handling a beaker that has recently had 120 millilitres of hydrochloric acid added to it. However, this solution would have very little effect if it got on your hands. To prove that all the hydrochloric acid has been neutralised, I did a pH test using litmus paper and I got a result of 7 to 8 pH, which is almost neutral. To isolate the boric acid that was on the sides and base of the beaker, I scraped the majority off into a filter funnel with some filter paper in. The rest was washed off the sides using ice cold distilled water. To remove any residual impurities, I needed to recrystallise my boric acid. To do this, I boiled approximately 150 millilitres of distilled water and added my boric acid to it. Just like earlier, I was taking advantage of the boric acid solubility drop at lower temperatures. The idea is that because sodium chloride is more soluble than boric acid at lower temperatures, the boric acid will precipitate once cooled and the sodium chloride will remain dissolved. The issue with this method of purification is that my yield of boric acid will be drastically reduced, so this step is not needed if a lower purity but higher quantity is required. Once everything was completely dissolved, the solution was left to cool down. Boric acid began crashing out quite quickly. To ensure that all the boric acid had precipitated out of solution, the beaker was put into the fridge overnight. This is what it looked like after coming out of the fridge. This was filtered and then the filtrate was discarded. To remove any residual water on the boric acid crystals, I put them all onto some cling film where they were placed in the oven at 60 degrees for about an hour or two. Once dried, the boric acid could be weighed accurately and I could calculate a percentage yield. Out of a theoretical yield of 109.1 grams, I got 39.6 grams. This represents a yield of 36%. Like I said before, I think that most of the boric acid was lost during the recrystallization step. However, it is absolutely essential that I have pure boric acid for the rainbow flame demonstration. I will now demonstrate the green electron light emission of boric acid. This is done by burning a solution of boric acid in a suitable solvent. A suitable solvent must be able to dissolve boric acid, as well as when it burns it must not release a very strongly coloured flame. For example, ethanol releases a yellowish flame when burned, however methanol releases a very neutral blue coloured flame, which is very weak. So I put a metal pan down and then put the evaporating dish with the boric acid on top. I then added the methanol. To overpower the orange light emission of the glass, I added some more boric acid.